Now we are going to see about the last topic in microprocessor and microcontroller. So unit 5, interfacing microcontroller. So in this unit we have already discussed two lectures, 8051 timers, 8051 serial port programming. This is the third lecture I am going to discuss. So today's we are going to see about the topic 8051 interrupts. So in 8086 processor we have seen in what is interrupt, what is the types of interrupt, so how the interrupt priority varies, so maskable, non-maskable, so many types of interrupts have we seen, int0, int0, int1, like that we are going to see about in 8051 interrupts. Interrupt is say external or internal signal. You have to know whether the microcontroller is whether receiving the interrupt signal or transmitting the received signal. Based on the microcontroller device only we are going to identify whether the interrupt is working or not. So another thing is the special type of parameter used in microcontroller is interrupt and polling. So we have to know what is interrupt, what is polling. So I have to go the difference between interrupt and polling. So interrupt can be monitored by interrupt service routine. So another thing we have to see that polling is just monitoring the status of the microcontroller device, whether it is working or not. We have to satisfy some conditions in polling. After checking the conditions, we have to monitor the conditions whether it is working for another device until the service is monitored from original device. So there are schematic diagram given for how the program execute without interrupts, how the program execute with interrupts. The program execution without interrupts, just we are calculating the time to the main program only. The program execution with interruption, we are calculating the basic time, starting time, and we are continuously monitoring the interrupt to ISR, that is interrupt service routine. If you are getting the transmitted signal, then we have to receive the original signal through interrupt service routine. So there are some following steps in executing the interrupt. First we have to, interrupt is nothing but program counter. So stack, we have to first set the instruction and save the program counter on stack. Then we have to fix the location where the interrupt have to pass the locations. When we are using special type of interrupt is return from interrupt. Return from interrupt only the interrupt service routine continuously get execution. From ret, the microcontroller will be able to stop the program and get the instructions to be interrupt through pop instruction through a stack. There are some basic steps in executing the interrupt. The same first step we are getting in signal program counter on stack, also save the current status to the interrupt not on the stack. Then we have to fix the location interrupt vector table. We have to know whether the priority given for interrupt vector table is located, whether to hold the address of the interrupt service routine. Then the microcontroller get the address of the interrupt service routine from the interrupt vector table and continuously monitor it. When we have to execute the interrupt service return until the return from interrupt execution starts. If the return instruction continuously execute, the microcontroller may able to return the value where it was interrupted. Originally there are 6 sources of interrupts. First one, reset, timer 0 overflow, timer 1 overflow, external interrupt 0, external input 1, then serial ports RI and TA. So RI TA already we discussed in serial port communication, RI and TA. Then TF0 TF1 already is coming TCON register. Then we have to see how the interrupt vectors varies. First one, interrupt vectors. So interrupt vectors has 5 numbers, 5 interrupt number 0 1 2 3 4. So for individual interrupt number we have individual vector address. So first one, interrupt number 0, external 0, interrupt number 1, timer counter 0, then interrupt number 2, external 1, and interrupt number 3, timer counter 1. The fourth one is nothing but serial port. If there are 4 types of interpolated registers. First one, TCON, SCON, IE, IP. So TCON is used for adjunct type bits for instant zeros and ones. Yesterday we have seen serial communication. So SCON is nothing but RI and TA interrupt plug used for RS-232 serial communication. IE interrupt enable, IP interrupt priority. So both things we have discussed in TCON register. How to enable and disable an interrupt. This masking and unmasking the interrupts. We have to see what is IE register. So IE register has totally 8 bits. Among 6th bit, 7th bit and 6th bit are enabled. So first bit is EX0 enable external 0 interrupt, ET0 enable timer 0 control bit, EX1 enable external 1 interrupt, ET enable timer 1 control bit, ES enable serial port interrupt, and EA is nothing but global enable and enable disable. So interrupt priority, we have several types of interrupts: INT0, TF0, INT1, TF1. This is the base. Highest priority is external 0 and lowest priority is serial communication RA and TA. So next we are going to see about IP register. So in IP register, first five pins are only active and last 3 pins are reserved. So PX0 interrupt 1 pin act as PX1 again interrupt 1 and timer 0 PT0. Next PT1 timer 1 pin, PS is serial port. So priority bit if 1 is assigned, it has highest priority. Priority bit 0, it assigns lower priority. So that's a small program given for how to create a square wave regarding interrupts. So first we are in question we are declared that port 17, a single bit of data, port 10, it sends a data to the port 10 and simultaneously a square wave of 200 microseconds with a period on a pin port to 0.5. Using timer 0 we have to create the square wave. Also we are fixing the crystal frequency as 11.05. This is a basic crystal frequency we have used. So we have to use timer 0 with mode 2. Yesterday we have seen about 8051 timer. The same concept we have to follow here. Then we have to declare include register 51.h. It is nothing but microcontroller basic register. Then serial bit SW status var S bit int, that is indicating the port 1. Then square wave to deny the square wave port to 5. So void timer 0 we have to interrupt 1. Then we have to declare the wave we have to declare. Then we have void main we have to declare. Then SW status var we have to set the value 1. Tmod we are already declaring the value 0 x02. Then TS0 0x A4. Then IE register interrupt enable we have to declare 82H. From interrupt table we are declaring. Then they are allocating a loop, and from the loop inside we have to declare the status var. So like if we generate the program in mnemonics 8051, the automatically the square wave will automatically generates. There are some basic questions regarding 8051 interrupts. What is interrupt? We already seen what is interrupt. What is the difference between interrupt and polling? What are the steps to be followed in interrupt? The same thing in detail we are declaring what are the types of interrupt: INT0, INT1, TF0, TF0, RA and TA. The part C we are declared same type of program, write an ALP program to generate a square wave of 200 microseconds. So thanks for watching the lecture regarding 8051 interrupts. If you have any queries, you kindly intimate me for clearing your queries. Thanks.